Hello everyone, my name is Veselin Pisarika, CTO and co-founder of Waylay. It's been a while that I have been recording my blog sessions. In the meantime, people start calling these vlogs, so let's call it a vlog. And today I'll be talking about Waylay versus decision trees, and I will be more in particular interested in looking at what is actually a problem with decision trees that few people are aware of. Now, many people know about curse of dimensionality in respect to data analytics, where they assume that as you have more and more dimensions, it's harder and harder to do the data analytics. But today I will try to explain how it's actually equally difficult to do rule engines and decisions based on multiple states or the outcomes of every given input variable. So in order to show that better, let's here see two input variables x and y, such as, for instance, temperature and humidity, where each of these can have a free states like low, medium, and high. If you would like to create a decision tree that depends on every outcome of this problem, you would in the end up with 18 leaf nodes, which lead basically to, in total, 31 nodes just to model that decision tree. And this is really something that become more and more apparent as you do really, if you like, real life decision tree implementations. I'm not talking about school examples, but eventually end up with this sort of problem. In order to actually show how that problem is real, I actually Googled something about decision trees and complex event processing, and I found one actually very good blog about implementation of the CEPs using the rules. So nothing wrong with the author, nothing wrong with the technology, if you like. And not to mention that you probably need almost a PhD to understand how to actually implement one very specific and very simple rule, at least it looks for, let's say, doctors or humans, how to look at a septic shock, and which is based on a rather simple tree, or let's say decision, where you need to have two issues with, for instance, temperature and heart rate, or you need to have a respiratory rate problem. So 2 out of 4 problems need to be present. Then to look at the source of infection, do you have infection or not, and then you look for some other measurements before you actually have a septic shock criteria, and then you create alerting and that sort of thing. If you look at the author, so he started with that, I would say, rather simple rule, if you like, that led to this sort of drawing, where you have 4 different measurements. Actually, he already simplified a little bit the tree itself, but I'm not going to go in details much here because there is already one missing here, just for the sake of simplicity, if you think. And further on, try to actually use decision tree tables with rules using the Excel sheet. Now, for people who are interested in the rules and Excel sheet, basically they should look at documentation of the rules, which is here, and I find it amazing that you go to such a complexity of the columns and rows, which is of course inherited from the problem of decision trees, but even more, you see that, as the author says in the picture above, you start mixing the code and the values and evaluations and conditions and so forth, and all of that even before you start coding. Okay, so probably would take a good developer, I would say, 3-4 weeks to get it working, and even then you will wonder whether actually stuff works or not. Now let's see how we do that in Waylay, and for that I just created one decision tree, if you like, using the Waylay Express capabilities, which is based on the logical gates backed by the conditional probability tables. But I'm not going to be that technical here. I will just show you what I have here. I have one of the conditions, which is whether you are above or in a range for a particular measurement, like respiratory rate and PaCO2, which is actually the one that, little one that you actually see here. So it is one of the 4 conditions, but that on alone is some sort of a logical OR gate. And then let's go for a bigger one, which is this one here, which expresses that 2 out of 4 problems need to be present in order to actually have that condition being true. So again, you here label 2 out of 4 issues to be always present. And then as you go further, then you have to check for infections. For here, I will check the customer database, then to have a sepsis criteria, and then I'm checking for SBP problem with a simple comparison of the value and the drop, which is expressed using our formula node. And finally, if there is also hypertension, I would check for a nurse and give her a call for with a message, something like alert. Let's make something longer, and then say the patient yeah, issue. So let's do that, and it will also then create alarm in our environment. Okay, so that's how easy it's to create or natural to create a rule as it is done here. And let's see how we debug the same thing here. I will just run the template in the debug mode. Okay, and then what I did is I created a small file which has some of the measurements like temperature, heart rate, and PaCO2, and I will see what happens. So let's go to the simulation. I will load that file, and let's start pushing this data every 5 seconds so I have some time to explain things as we go. So let's start a simulation, and we'll start pushing the temperature, heart rate every 5 seconds as you see here. Okay, we come here and we start seeing whether we have for each of these measurements condition as expressed by the rules itself. So you see here finally we have measurements and evaluations, and let's for the moment assume that we have an infection. What I'm going to do now, I'm going to just change it myself, infection in this setup here to be true, and let's imagine that there is a nurse around. So I will just have here something that comes from the external system that says that there was a nurse around, and as you probably can hear now, this is my call, and I can stop now the whole thing. I've got a call that the patient was in trouble, and let's go back now to my resources. So I was pushing that to the patient 1, and here is the data that we have been pushing for the past, and we're still actually pushing that, and you see the alarm critical for the septic shock alert, which is here.